These slides go along with page 744 and forward in your textbook. You've already learned how to factor a quadratic expression. We're now going to use that knowledge to solve a quadratic equation. We're finding factors of -5 that add up to -4. 1 and -5 do the trick. So the expression x squared minus 4x minus 5 factors into the two binomials x plus 1, x minus 5. Now the reason that helps us solve a quadratic equation is because generally, as we've found out in the past, a quadratic equation will have two solutions. It will cross the x-axis in two locations. Therefore, in order to solve our quadratic equation, we're going to need to break it up into two equations, two linear equations, so that we can have two answers or two solutions. Factoring is how we break it apart. The reason we can do that is a property of real numbers called zero product property. So we're going to take the factor x plus 1 and set it equal to 0 all by ourselves. And then you already know how to solve a linear equation for x. Isolating our x, we're going to use inverse operations. So we're going to subtract 1 from each side, and x equals 1. The other factor was x minus 5. We're going to set it equal to 0. And again, use our inverse operations to isolate our x, just like we learned in Algebra 1a. Add 5 to each side, so x equals -1 or x equals 5. And as you've learned already, a good way to check your answer is to substitute the value that you just found for the variable. So go back into the original equation and plug in -1 for all your x's and solve and make sure it's correct. And then do the same thing with your -5. Plugging them right into the original equation to make sure they work. Now turn the page. We're going to look at this equation that we just solved a little bit closer. If you're able to graph the equation on a graphing calculator, or alternately, find your vertex using find your axis of symmetry using x equals -b/2a, plug it back in and find your vertex. We already found the zeros. Use those to graph the equation. You probably found that your vertex is 2, -9, your y-intercept is 0, -5, because as you recall, your y-intercept is your c value in your original standard form equation. Your x-intercepts are -1, 0, and 5, 0. That's just what we found when we found our solutions just a moment ago. And your axis of symmetry is x equals -2. And there it is. While we were at it, we also graphed the line y equals 0. And what we discovered was, as in question D, the x-intercepts of the graph are identical to the solutions we found in question 1. They're the same. And when we find the intersections of y equals 0, in other words, the x-axis, to the original equation, to those solutions, we find out they are also identical. They are also the same. Basically, what we're saying is the solutions, the roots, the x-intercepts, and the zeros are all basically the same concept. Four terms that mean more or less the exact same thing. Roots, zeros, solutions, x-intercepts. So when you get to test time and it asks you to find the roots, and you're not sure what that means, it means find the solutions. It means find the zeros. It means find the place where the graph crosses the x-axis. Now I suggest that on page 746, you just go ahead and mark that page however you like. Pull it out, stick it in the front of your binder, highlight it, star it, fold down the corner, whatever you personally need to do. Find that page quickly. That's the page with the steps to solving a quadratic. And the next several pages are just practice problems that we practiced together in class to get used to using those steps. To get used to factoring a quadratic equation and breaking it apart into two linear equations. That's all we're doing. We're using the factoring that we learned in 12.3 to break our equation up into two linear equations so that we can have two solutions. Your first step is get it equal to 0 when it's already equal to 0. Your second step is to factor it. And your third step is to break it into two linear equations to set each factor equal to 0. And now you know how to solve two linear equations. Use inverse operations once again. There's your solutions. I suggest that you try each problem in your textbook. Pause the video, try it, and then come back and see if you did it correctly or see if there's any mistakes or misconceptions you need to correct. That'll be the best way to practice it. Please try to do every problem first before you watch it on the video. because you'll learn it better that way if you try, even if it's hard. Step 1 is to get it equal to 0, and we did that. It's already done. Step 2 is to factor it. Step 3 is to break it into two linear equations, setting each factor equal to 0. And step 4 is to solve those two linear equations. Number 5. Again, this is already equal to 0. We don't have to manipulate the equation at all. We just need to factor it. Set each factor equal to 0. And solve for x. Now please, again, don't just watch this like a movie. Try them first. And then check to make sure you've done them right. Pause the video and try them first. Number 6 is already set equal to 0. But we're not going to factor this into two binomials, are we? Because it's not a trinomial. It's already a binomial. But it does have a greatest common factor. My GCF is x, so I need to factor the x out. But even though this looks a little bit different, there are still two factors here, x and x minus 11, and I still need to set each factor equal to 0. So it's really no different, even though it looks different. Number 7 is not in standard form yet, so we need to get this in standard form. We need to transform this equation so that it is set equal to 0. That means let's get rid of that negative 7 on the right side of the equation. Let's just use inverse operations and add 7 to each side of the equation. And then now that it's in standard form, let's just factor it. Set our factors equal to 0. And solve it for x. Again, just use transformations to get it into standard form. We want it to be set equal to 0, which means we need to use our inverse operations to make it happen. And now that it's in standard form, factor it. Set each factor equal to 0. Now this is what we call a double root. X equals 9 is our answer both times. So it's a double root or a double 0. You don't have to write it twice. Just write x equals 9 one time. This is just one of the rare occasions where a quadratic equation has one solution instead of two. This is a quadratic with a leading coefficient of 3. We learned how to factor these also in 12.3. Go back and refresh your memory with your 12.3 notes if you've forgotten how to do that. Once we've factored it, we just set each factor equal to 0. And we solve for x. Don't forget, divide out that 3 at the end. And because you have to do that, you end up with a fraction for an answer. That's okay. Please don't make it a decimal. Please leave it in fractional form. x equals 1/3, or x equals 7. Same thing here, factor it, put them equal to 0, and solve. And again, please leave them fractions. X equals -7/4, or x equals 3/2. Don't change them into mixed numbers. Don't change them into decimals. Just leave them fractions. Okay, if you were in class, your ticket out was 749, 1 through 5. If you weren't in class, why don't you try those out now? And when you come back to class, show them to me, and let's make sure that you've got this under your belt. When you're feeling like you understand completely, why don't you start the skills practice for 12.4.